So today we're diving into one of the most versatile, and I mean truly important families on the entire periodic table. We're talking about group 14. These elements are literally everywhere, from the building blocks of you and me to the guts of the phone in your hand. Okay, let's start this off with a bit of a riddle. Take a look at these three things: a diamond, a pencil, and a computer chip. I mean, at first glance, they have nothing in common, right? One's the hardest thing you can find, one's so soft it leaves a mark on paper, and the other one, well, it runs our entire world. But they all share a deep, fundamental secret.
And that secret is, it's all in the family. Their chemical family, that is. Every single one of them owes its unique properties to a single column on the periodic table, a family of elements with an absolutely incredible range of talents.
All right, so let's properly meet this remarkable family, known in the chemistry world as the group 14 elements, or, if you want to get fancy, the Tetragens. So check this out. You can actually see the family's personality change as you go down the list. Right at the top, you've got carbon, a classic nonmetal. Then as we move down, we hit the metalloids, silicon, and germanium, which are kind of like the teenagers of the group, having properties of both metals and nonmetals. And then at the bottom, we get to the full-blown metals, tin and lead. So, what makes them a family? What's the thing that ties them all together? Well, it all comes down to their atomic wardrobe. Every single element in this group has 4 electrons in its outermost shell. And that means they all love to share those 4 electrons to form bonds, giving them a common oxidation state of +4. But here's where it gets interesting. There's this quirky family dynamic called the inert pair effect. As you get to the heavier members of the family, like lead, 2 of those outer electrons they get kind of lazy. They just don't want to participate in bonding anymore. And this makes a +2 oxidation state way more stable for them. Okay, now we have got to talk about the undisputed superstar of the group, carbon. We're about to see what makes this one little element so incredibly powerful and, essential for pretty much all life as we know it. So, why is carbon so special? Well, it really boils down to 3 key things. First, it's tiny. Second, it holds onto its electrons really, really tightly. And third, it has a much simpler electron shell structure than its bigger siblings. All of this together gives it chemical powers that the rest of the family can only dream of. And here it is. This is carbon's biggest superpower. It's called catenation. It's this incredible, unique ability to bond with itself over and over and over again, forming long, stable, mind-bogglingly complex chains. Seriously, think of it like the ultimate chemical Lego set. It can build almost anything. And wow, this chart just says it all, doesn't it? Look at that. Carbon's ability to form these chains, to catenate, is just completely off the charts compared to everyone else in the family. I mean, silicon gives it a shot, but then the ability just plummets as you go down the group. It's not even a competition. So because it's so good at building these chains, carbon can show up in all these crazy different physical forms. Even though it's the exact same element, the way it's put together can be totally different, and we call these different forms allotropes. So let's put its 2 most famous faces side by side. On one hand, you have diamond. Here, every single carbon atom is locked into this super rigid 3D web, which is what makes it incredibly hard and a terrible conductor of electricity. But then you have graphite. The atoms here are arranged in flat sheets that can just slide right past each other. And that's why it's soft, slippery, and a great electrical conductor. Same element, totally different worlds. I love this analogy because it just makes it click, Diamond is like a house built with a jungle gym of interlocking steel trusses, unbelievably strong. Graphite, on the other hand, is just like a stack of playing cards. The cards themselves are strong, but the whole stack can just slide apart with a little push. And believe it or not, the story doesn't end there. Not even close. Scientists have cooked up even more amazing forms of carbon. You have fluorines, these incredible cage-like molecules that look like little soccer balls. And if you could peel off just one single atom-thin layer of graphite, that's graphene. And then if you roll that sheet up into a tiny cylinder, you get carbon nanotubes, a material that's literally stronger than steel. All right, let's head one step down the periodic table and meet the family's other genius, silicon. We're going to see how it uses its own talents to build a completely different kind of world. So, if carbon is the architect of life, silicon is the master architect of high-tech materials. Its most famous creations are silicones. These are polymers with this tough backbone of alternating silicon and oxygen atoms.
And they are famous for being incredibly stable at high temperatures, which is why people call them high-temperature polymers.
So how do they make this stuff? Well, it's kind of like a two-step recipe. First, you take a starting molecule and react it with water. That's called hydrolysis. Then, in the second step, those little pieces start linking up together, kicking out water molecules as they go to form the long, super stable polymer chains that make silicones so special.
And what you get from that process is this amazing material with an awesome set of skills. It repels water, it's a fantastic insulator for both heat and electricity, and it stays slick and stable even when it gets super cold. That's why we use it for everything from specialized lubricants to the stuff that makes our raincoats waterproof. But silicon's biggest job? It's literally holding our planet together. This number is it's mind-blowing. 95% of the Earth's crust is made of silicon compounds, silicates and silica. Our world is, in a very, very real way, a silicon world. And hidden within that massive family of silicates are these incredible materials called zeolites. They're these 3D crystals that look like a microscopic honeycomb. The cool part is all the pores in that honeycomb are exactly the same size. This lets them act as a molecular sieve, a perfect filter that can trap some molecules while letting others pass right through. So when you really step back and think about it, it's just wild. You have carbon, the element that is the literal backbone of every living thing, and right below it, you have silicon, the element that is the foundation of our planet and all of our modern technology. This one family really has built our entire world. It just makes you wonder, what on earth are they going to help us build next?